Hey, calculus class. Let's look at another example from the chapter 3.5 homework set. So we're being asked, does this have any horizontal tangents in the interval? So one thing we can do is graph it and see if it has horizontal tangents. And then I'll show you just the calculus to do it. So if I take this function and graph it, so just to recall, I use f of x notation here instead of y equals like the original problem uses because that allows me to do things like f of pi, and I can see different values. All right, let me make sure my mode is right here. I am in radian mode. Okay, we want to make sure you're in radian mode with this. This is the derivative, the tangent line notation. Let me make a little slider here just to remind you what a tangent or the derivative is and what the tangent line is. So I'm going to do a is negative 2 to, let's do positive 3. And I'm going to make this tangent line. So the tangent line is the derivative, that's f prime, at some point. So I'm going to use a as my point. And then this is just point slip form, x minus the x coordinate. So a is my x coordinate plus the y coordinate. The y coordinate is f of a. And anytime you do that, you end up with a tangent line. I'm going to make it black and dashed. And what you want in this problem is a horizontal tangent line. And what we're going to find out as we go along, I'm going to also label this a, f of a. That's just like an x, y coordinate. What you're going to find out is when you have a horizontal tangent line, I changed the view a little bit so I could get a better estimation of the horizontal tangent line. So right there, the tangent line is horizontal. And what we mean by horizontal, remember a horizontal line is just like y equals a number is a horizontal line. So like y equals -4 is a horizontal line. So when we say a horizontal tangent, it's the same concept we've been talking about, tangent lines. A line that touches the curve on a point and only one point on the curve immediately is gone. But we're also using the adjective horizontal. And that means the tangent line, the line itself, is horizontal, meaning just like y equals -4 that we just saw before, it's parallel to the x-axis. It has a slope of 0. So what we're hopefully seeing and finding out as we go along with this section, this homework set, and just this chapter in general, is horizontal tangent lines occur at these peaks and valleys. Now, one really cool thing about Desmos is when you click on a graph, it automatically gives you the location of horizontal tangents. All right. Now, this problem specifically asks, though, are there any in the interval 0 to 2 pi? All right. This is not in that interval. So I always just encourage you guys to learn to use this wrench tool. Make your x-axis go from 0 to 2 pi. And again, what you're looking for are, let me go up a little higher, are places where it drops down and goes back up, or it rises and then comes back down. So there are a couple of values between 0 and 2 pi that occur here. Now, what you're after when you're being asked these questions are these x coordinates. So pi over 3 and 5 pi over 3. Now, to get those to show up, I used 0 to 2 pi, and I used a step size of pi over 12. You could have probably gotten away with this time, but with like a pi over 6. And it shows more values along there. But that's what we're after here, is those x coordinates. So pi over 3 and 5 pi over 3 are where we have those horizontal tangents. Now, how do I do that? Let's do, that was the window that we did. Now, how do I do that with calculus? Well, the math involved has us to A, find the derivative. I'm going to say this is dy dx. And the derivative of this is the derivative of 5x is just 5. And the derivative of -10 sine x is -10 cosine x. And now remember, this is the slopes of the tangent line, right? And a horizontal tangent line, or any horizontal line, not just tangent lines, but any horizontal line, has a slope of 0. So since the derivative gives us the tangent line slope, and we want to know where is the tangent line horizontal, or if we have a horizontal tangent, that means we're going to set our derivative equal to 0. And so this works out the equation. If I add this 10 cosine x to both sides, I end up with 5 equals 10 cosine x. If I divide both sides by 10, I end up with 5/10, or 1/2, is equal to cosine. So this is a trig equation. So now we're thinking about a unit circle. And if you remember, on a unit circle, the cosine is the x-coordinate of the points on the unit circle. So we're only looking at these x-coordinates, and we're being asked, okay, where is the x-coordinate on these points on the unit circle equal to 1/2? And we see it happens right here. So there's just positive 1/2. If I go down here, there's another positive 1/2. And notice that's our two solutions to this. Where is cosine equal to 1/2? That's where these x-coordinates on the unit circle are equal to 1/2. And that happens at pi/3 and 5pi/3. And that was the solution that we got on Desmos as well.